Hey guys, welcome back to the channel. I have another test video, this time working on a 2009 Subaru with a 2.5 liter turbo engine. David John, this is your computer. Not really much to go by. The only concerns, the concern that he has is lights comes on but will not crank. It says in-dash, temperature light backs and 4 blue-red flashes. Please call with any question. If best. I think David, that we need to do a little more homework on the car to see what the light flashing is, if you have any immobilizer or something, because this car has an immobilizer. And reading the information in a snap-on, which Subaru, I don't know why, it has since ever, right, give you very minimum diagnostics usage through scanners. I'm not sure how the dealer, because I've never worked for a Subaru dealer, but with a snap on any of the scanners, there is almost no bi-directional controls. There are very minimum things that you can do that in other cars you got, huge list of things to do. So Subaru, no good. And that gives, or ties my hand up, because it's things that I cannot do, like, apply the starter relay to see if it's working. I have checked his computer. Let me just move you over here. As you see, I have it open up. This computer has 4 connectors, so A, B, C, and D. They start with a B134, B135, B136, and B137. Again, A, B, C, D. And you're going to see the connections I have made from one of the wire diagram images. I put all the connectors in place and pull all the signals that I need to do a bench test and also to connect to the scanner. So I just connected the ECT, engine coolant temperature, to see if it's something that I can maneuver, and then show David that if that is reading properly or not, which that should not prevent the vehicle from starting. No temperature. Even if your transmission temperature is high, it should not prevent the car from starting. Not really sure Subaru, right? So let's see what we can do here. So I got a meter connected to the 5-volt reference and sensor ground. And before we go there, let me show you the connections. So I have made, again, from 13 pages of decent type of diagrams. Subaru, again, at least coming from the direct hit or Identifix, I don't have any other access, but I can show you in his folder. These are all the wire diagrams. If you try to use the color wire diagrams from Identifix or from any other source, all data or whatever, you will have to follow each wire to find out what it's going for, because it has absolutely no naming on any of the pins. None. And I can scroll down so you can see that that is indeed truth. Let me just keep going. So nothing has any naming. Like I always said, you see, this is the other 2 connectors. So I got all the pin numbers in the B134, B137, but you will have to follow each line at a time to find out what that is. So very, very unuseful, The diagrams are separated page by page on Identifix, so you have to download each and start to reading each. And that's what I did. I went through each page to see which one was the grounds, which one was the powers, communication lines, the coolant temperature sensor, 5-volt reference. So it was very time consuming to get this connected. I don't work in Subarus too much, so I don't have a made harness for it, because again, it's a 2008, so this is on its way out. Even though Subarus are really good vehicles, I don't, and probably that's why, right? Because they don't get here too much. But yes, you can see, not click here, no hyperlinks, no absolutely nothing to help you make these connections or tests faster. So what I did, again, it was created this. So you can see this is just a starter wire diagram, and I pick it for obvious reason. He has a crank no start, a no crank. This is a no crank condition. So the only things in this is based on what the scanner reads. This is an automatic transmission, and I have tested to see if I have an automatic or a clutch switch or because if this is an manual transmission, you will have a clutch that you need to press in order to have that wire going or receive that voltage into the computer. And I have tested everything and make no sense, no difference whatsoever for my testing here. So automatic or manual, I will be able to do the cranking, but it's not happening because I don't have the immobilizer. And in this car, it's not bi-directional control like I mentioned in the beginning. So yeah, in the left side, I move all the connectors. So we have connector A, B, C, and D. As you see, all the pinouts. Those pins are the harness side. So it's kind of like you will be facing the harness disconnected from the computer, facing it forward. So it's kind of like in reverse as you connect it here. So I have to work like a dentist to connect this because, again, there's no wire sequence to follow because it's just an inconclusive color wire diagram, and these are page by page based on different things. Let me just show you what they do in page 1 for the engine. So this is what you get in there. Look at this spaghetti. I don't know how the technicians work with this on the dealer because there is no color wire diagrams. There is no hyperlinks. I mean, you're in a stone age, Subaru. I'm sorry, but if this is what you're giving your technicians in the field, poor guys. I'm serious. This is like sad to see a diagram, black and white. I mean, how can your brain pick up or remember anything in here? I mean, in following, you cannot select, you cannot click. There is so many different lines that are jumping to the next one. Believe me, this took me like 2 hours to get all the signals and everything properly connected, because when you are in the vehicle, well, I guess you can go into one connector and see if you have the powers and grounds in there. But when you don't have the vehicle and that you don't have the connectors, you have to make sure that where you're connecting is properly, because otherwise you will cook the computer here. So this is a little time, not a little, a very big time consuming connection. All right, so we have the connections in there. Power, I have battery positive or constant battery, terminal 30, and connector B, pin 5. Ignition, terminal 15, is in connector B, pin 19, and in connector C, pin 25. Battery positive through a relay, which I always will call terminal 87, are in connector B, terminal 2, and connector A, terminal 7. For my test here on the bench, I have all the grounds for the computer, which are in connector D, pins 1, 2, 3, 7, and connector A, pin 5. All are interconnected into the computer, so they're, for me, all the same ground, so I'm using only one ground. Communication, this computer is a CAN bus, but also has a K line and pin 7. So, and that's what I put, DLC7 is the K line, DLC6 is CAN bus high, and DLC14 is CAN low. So communication will happen, and it has to be connected. Otherwise, you will read the beam, but it will not read the diagnostics. So that is for diagnostics. C16 is DLC7. C, again, connector C. Pin 27 is DLC pin 6. Connector C, pin 35 is DLC pin 14. The fiber reference, I'm checking it all, and they're the same. Is in connector B, pin 22. The start relay, which is a negative activation, and we can see that here on C20, which is right here. If we follow the control side of the relay, this is the contactor side, so this will provide power when this is closed. But the contactor side, sorry, not the contactor, the control side, this part coming from the computer is the negative. Why? Because the other pin is going to a fuse. Fuse power. The main relay is in, I didn't put the C in there. So that's C23. Let me correct that 1 second, guys. All right, quickly just corrected that, because otherwise I will not remember later, right? So what pin, what connector, right? So pin, yes, 23, but which connector? Otherwise I will have to follow that and find it again, even though it's, we can see that here, right? So C23. It's a main relay. Actually, I didn't notice that the main relay is actually here too. So we can see C23, when it's controlled by the computer, will turn on the relay for the oxygen sensors and also the main relay, which when this is controlled, it will close this contactor side and it will provide power on pins B2 and A7, which are the ones that I have here. I forgot to mention that B2 and A7 for the computer, there are the same pin. So if you have power in one, you will have power in the other one. So that is terminal 87. And then no, actually I didn't see a coolant temperature sensor is in terminal connector A, terminal 34, and then the start request. The start request is very important. Is C32. Let me see if it's here. Yeah, C32. And then you see I put it positive because if we follow right here, so it's coming directly from a fuse. So this is a constant power, but it's only when the ignition is in the start position. So even though it's a constant power, it will only be there when you're cranking. Only when you're cranking. When you're not cranking, that will not be there. And it's very important, David, that you check that signal. Those are the recommendations that I want to give to David. So please take a picture of this page that I have here, because we will be working with this. Because I told David I cannot see anything wrong with the computer here. So we're gonna have to send it back and do more tests on the car to see what the problem is, because I hardly doubt that the computer never seen this not crank condition and then being the computer, unless you have a no communication or problems that, you know, the computer is bad, it's water damage or something like that. But this computer is looking like pristine. There is no capacitors leaking, nothing that I can see, and I'm been going through the microscope and everything really deep, and I could find anything. But again, so that will be only there when the ignition is in the start position. And we can see, you know, this has also an inhibitor switch. This will prevent the starter from engage, because the power will go from here, right? So looking, and also this is just a confirmation, and C31 will have a confirmation from the same relay that the contactor has been closed. Because if the computer sees power here, right, it will say, okay, we're cranking, and want to make sure, you know, that we're cranking, we're widening our injection millisecond to allow that engine to start as quick as possible. So that's why that signal is in there. But if we follow that same wire, this goes into this inhibitor switch, which is not saying in here, but this is usually either close to the fuse box or next to the transmission. It could be either one. In this case, if it's an automatic, it will probably be in the left side of the transmission. Let me just see if I have that one in here. Let me just see, star color, star diagram. You see, this doesn't say where it's located. It just gives you the connector. You see that D7 here is the same connector we have at the bottom. When I'm in a PDF, I need to get a box like this so you can see me when I'm moving. Let me make it a little bigger. Yeah, so this is the inhibitor switch, the same one, right? Is the park neutral switch or whatever. And we have it's a 7-pin connector. Sorry, not a 7-pin. It's called T7, and it's 9 wires. And this is right here at the bottom. But let me go into, I keep clicking the wrong thing. Maybe in the color, right? Sometimes the color will give you more information than what you can read on the original, because this is a redrawn wiring that was done by somebody else, and they take the time to read the information and try to guide the technician as best as possible. So yes, it says that in the case that you have an inhibitor switch, it's in the right side of the automatic transmission. All right, so that's so you know. And this will cover here automatic and manual. All right, guys, so enough talking. Let's go over to the test, right? All right, so I got this scanner ready in the meter. So let me put the SUS in the screen. I gotta make that a little bigger so you guys can see better. Let me give you that 1 second. Okay, now we're selecting that. So I'm just gonna make this a little bigger and move that multimeter out here. So yeah, you will see better, because we will be focusing mostly in the scanner. And yes, you will see some results as soon as I turn the ignition on. We have, let me just remember how I have this. So this is the main relay, and this is the starter relay. I'm going to make this face down, because otherwise it will be facing me, and that blinds me. All right, we're gonna turn the power on now, and we can see the main relay coming on, no start. I have put that signal that we were referring before, the start request signal, into the third switch on my universal box in here. So I'm going to put that, but like you said, there's no start relay activation, so it's not controlling the starter relay. So let's go over to the scanner because this is what I wanted to show you. We have fiber reference and sensor ground present, David. So this is no problem in there. So let's connect to the car. Oh, I have not connected the VCI. So let me plug this in here. Sorry about that. In the meantime, that connects. Let me get some water. And I just spoke to David, I don't know, maybe 20 minutes ago or so ago, before starting the video. I tell him, I've been doing the test since yesterday and I cannot really reproduce. And these are computers that are a loss for me because hours and hours of testing something just to collect a test fee is really not profitable. All right, so this is going to, as you see, start by itself doing an automatic ID, and that is the big number. I forgot even to mention. So we have 751917, and probably, not sure if you can read that, but it's here, 751917 on this page that he sent me. All right, this is a 2.5 turbo. So we're going to select that, and we're going to go click OK, and we're going to enter in the engine. I'm going to read the full code first because and then go over to the troubleshooter that Snap-on has. So Snap-on is at least good on that way. And I'm going to show you why. So if we go over to codes and we go over to manufacturer specific, realistically either one, current codes. It's a little slow reading, and that is just because it's a Subaru. But what I want you to see is that P1572 immobilizer circuit failure, except antenna circuit. So that means that we have no immobilizer. So the vehicle is immobilized. And of course, we don't have the VCM, we don't have the antenna, we don't have the instrument cluster, and we don't have the car key. So yeah, but some vehicles, even when they're immobilized, what they do is either they cut the injectors or the coils or both, but not the starter. But some vehicles, they prevent the starter, so they inhibit the cranking condition, so you will not even be able to crank the car. This is where I need to do more tests with David, because I'm not sure with here, without being able to perform a bidirectional control, and that's the next thing that I want to show you. So actuator tests. It's telling me to, put the vehicle in test mode, this is ridiculous. So again, another more thing to do. And instead of just going actuator mode, they want the technician to go under the dash and jump a wire that is a green male and female block, and then so the car can go into test mode. Are you kidding me? What is this? A Stone Age? Do I have to spin the the lever on the front to crank the engine? Wow. But yeah, so that's all the bidirectional controls that these computer allow the technician to do. AC compressor, canister, fuel pump relay, PCV solenoid, radiator fan relay, secondary air, secondary air pump, turbo waste solenoid, and bend control solenoid. So how about the starter relay? Nothing on that. So we cannot do a test. You cannot kill the injectors. You cannot do anything. So this is, again, one of the worst bidirectional control computers that I have ever worked with. This is like, if you work with Ford, Dodge, or any American vehicle, Toyota included. Toyota is great. I love Toyota. Toyota gives you pages of pages of pages of pages of data and bidirectional controls. Why? Because they need to do that. They understand that the technicians are in the field trying to repair a car that they sold. So let's give the best tool possible. These guys are like, oh, no. Send me this to the shop and we're going to spend days repairing something that, another manufacturer can repair in 5 minutes. A very, very weird mentality. And again, since I don't have the original scanner, all I can see is what these ones would do. So we cannot do bidirectional control. So that is already a problem for me. So going over to troubleshooter, we're going to engine, and you can go into time savers, general information, tests and procedures, test the part, starter motor. Let me see what it says in here. Yep, that's exactly what I want you to read. So no start, no crank after, a starter motor circuit. possible open or short circuit, poor connection, or failed component. Test for main power of the starter and a starter signal from the inhibitor switch at or interlock relay if it's manual transmission. If no signal for the AT, inspect the signal through the inhibitor switch, verify switches in park or neutral, verify signal from the ignition switch. For manual transmission, inspect the clutch switch for continuity. If okay, right? Verified signal on a starter interlock relay. If no signal, suspect failed ignition switch, which is very common as well on this car. And David, you might have a problem right there. That's why I need to understand what are we missing. Yeah, but look at the last final note. If vehicle is equipped with security system, possible security system interrupting the start signal. What is the security system? The immobilizer system. So yes, and it will prevent the start signal. So that is where my hands are tied. Why? Because I cannot do a bidirectional control and I don't have the entire system. And they was, oh, maybe I can send you the instrument cluster. I'm like, no, it's not just the instrument cluster. It's the instrument cluster, the BCM, the antenna, the key. So you're going to take the entire car out to send it to me and I have to redo a whole harness and try to do the test just because we cannot do it in the car? No, yes, we can do it in the car. We already have everything in there. So instead of me doing the heavy load work, let's do it on the car. Let's you do the vehicle testing and get me the data. I need to know what are you missing. Are we getting the start signal going out? And follow the recommendations that I have read in here. If you have a problem, no start condition, we need to understand what are you missing. And that is not the case in here, right? So let's go now back to the coolant temperature because I told David, that I was going to check the coolant temperature in the data pits. I have connected my auto simulator here, so I will inject the signal over to the coolant temperature to see if we see anything. So engine data. And let's see, yeah, coolant temperature is in 174. I'm going to customize this because we don't have anything else connected. And I told this to David. I mean, reproduce the entire vehicle here is impossible to try to find what are you missing. I need you to, with the vehicle that you have everything connected, start to go and see what is exactly preventing the vehicle from starting, from cranking, right? So it's only two different things. If it's an automatic transmission, the inhibitor switch at the transmission, see if you have the signal before, and if it's not going through, well, that is the problem. Is the ignition switch sending the start signal? Because we don't have any of those values, any of that data here to go by and see what are we missing. Okay, what was that? An error on the scanner. We're going to deselect that, and we're just going to select the coolant temperature sensor, and we're going to put them in a graph. All right, so now I'm going to change the coolant temperature in my simulator, but we can see how the scanner is reading properly. You see, I can go up into hot temperature or very cold temperature, you know, like 20 degrees, 0 degrees. Right now, we got 0 degrees Fahrenheit. And right now, I'm going into around, 59, 73, 84, 195. I actually went too much. But we can see how we can change the temperature. So the coolant temperature signal is being read by the computer properly. So you either have a chore in the harness or something else that I cannot reproduce in here. I cannot say the computer is perfect, but based on the very minimum data that I have here to go by, I can tell you that your fiber reference and sensor grounds are good. Things that I can, or I have at least proved here, and this is where data is very important. You see all that data that I have collected, all the wire diagrams, writing my notes, doing a video. This is data that I can recall at any time, and so is David to go back to wire diagrams. This is what I call collecting data, and I'm a data analytic person. That's the only way you can diagnose a car. So yes, in this case, we know we have a good sensor ground. We got a good fiber reference. The main relay is on. I cannot do things I don't know. Is the computer starting or sending the start signal just because I don't have the immobilizer? No, I had done the park inhibitor switch in here, and it's reading good. So I can put that in, and that will be only the park and neutral switch. But and I can probably just show that in the video. So give me 1 second. Well, guys, I cannot. Another this actually has its own module for the transmission, and those signals goes over to the transmission module, and the transmission will send that as a message over to the computer and over to the immobilizer as well. Let me just show you that. So let me take the SUS out of the equation and that, and let's go over to here. And this is a color wire diagram, but again, so we have on top of me right here, right? We got the automatic transmission inhibitor switch, which we can see it has different signals. So the first one right here is the signal for the starting, but then park and neutral goes directly to the transmission control module on connector B55. So there is no other park or neutral signals into the ECM. So this will go again into the transmission module and as a message over to the ECM. All right, so guys, another step that we have with this Subaru as far as even those signals. And again, the 08, 07, you were able to read those, but not in here. So this will need a complete vehicle. So David, what we need to do is connect the scanner, check to see if the transmission module is reading the neutral and park position, because if it's not a neutral or in park, and it will not crank because the transmission thinks that you're in gear or not in park or neutral. So, and it will not crank. So we need to make that do that test. But that's it. All right, guys, I hope that you like the content. This is more of diagnostics and helping the customer to try to diagnose his vehicle than a repair here. But I think it's valid and it's good, and it's going to help a lot of people as well with probably the same problem. All right, guys, I'll see you next time. Bye-bye. And if you're here, don't forget to subscribe. Hit that thumbs up and help my business, my small business. Every time you subscribe, YouTube promotes my videos more and more, and that's how you find me. It's for free. So if you do so, thank you so much. See you next time. Bye-bye.